Level 3 synthetic fingerprint generation, paper ID 2551. So there is a variety of fingerprint sensors that can capture the biometric information, translate into images. A low resolution sensor can generate a level 1 image that you can see here on the left. Here in the center we have a level 2 image that was created by a mid-resolution sensor, and we can see here the presence of minutiae such as bifurcation and end of line. Here on the right we have a level 3 image that was generated by a high resolution sensor, and the most relevant thing of those images is the presence of pores on the ridges that increases the accuracy between fingerprint matching. But nowadays publicly available level 3 databases such as PolyU, it's not more available, and this hinders the evolution of biometric algorithms. So to solve this problem we created our method, and our method is split into 2 stages. And the first step is to create a master fingerprint. So we used Angular to create a master fingerprint, and we modified the image of Angular to increase the variability of ridges thickness. So you can see here on the center that the ridges are thicker compared to the borders. After we created pores and scratches into the images. So we follow a real distribution of a real database to sample the pores into ridges. The scratches, we annotate the number of scratches in a real database, and we put the scratch in a real random position, and we created line segments, and between those segments we chose a random angle to create the variability. So here we have the before and after the process, and this image we call it L3 master fingerprint. After we perform the acquisition simulation, so a real sensor has a limited area, so we have to replicate this, and we follow also a real distribution of a real database to crop and rotate those images to create multiple instances of the same identity. We call this image a seed image. So after we performed a textual translation using Cyclogun. So Cyclogun was good to perform this translation between 2 domains, a seed image into a realistic L3 fingerprint. So we performed a visual comparison between our fingerprints, synthetic fingerprints, with a real database, PolyU database. So you can see here that we have similar features like characteristics, also with different background colors, textures, and also scratches. Characteristics that is present in a real database also is present in our synthetic database. Also, we noticed that L3 traits such as open pores here and closed pores. We also notice here in the center incipient ridges and also distinct ridges contours. We also compared our results with other methods, and the results was that our method is the new state of the art. The quantitative results, the objective of our experiment was to see if both the real fingerprints and our synthetic fingerprints was in minutia matching and pore matching has similar behavior, and we performed the minutia matching, and we can see here on the left that both have similar results, and also here on the right a similar result in pore based matcher. Also, we performed an experiment with participants that they classify images, real versus fake images. So they classify the images that they consider false. And our results, we found that the people, the classification error was 50%, or close to a random number. Our contributions is that we created the first method to create a L3 synthetic fingerprints, and we also can create multiple instances of the same identity on those fingerprint images. We also published a public database and this database contains 7,400 images and also 740 sweat pore annotations. So thanks for watching.